Hello, chemistry students. How are you doing today? I wanted to post a video just doing a couple examples from your worksheet number 5, which was actually due today. And going over that PowerPoint that I gave you the other day, talking about single replacement reactions. There was a couple things that I wanted to make sure that you understood before we move on. The first thing is that single replacement reactions are when you have an element and a compound reacting to form a different element and a different compound. So if we were going to write out a simplified form of this, we would have this is our element and our compound reacting to form a different compound and a different element. Okay, so this would be like the generic form of it. So we might have something, if I was going to do an example, we might have something like lithium, okay, plus our, like we could have zinc acetate, reacting to form. And in these reactions, your like replaces like. So if you have a metal element, it's going to replace itself with a different metal. Like the metals are going to switch places. If you had two non-metals, they switch places, then the two non-metals switch places. So in this situation, we have to look at our activity series, and you should have been able to print this out to see whether this reaction will actually occur. And on our activity series, here I'm going to fold this. On our activity series, these are listed with the most active metal at the top and the least active metal at the bottom. So we have lithium at the top, and then it lists a whole bunch of metals, and silver is the least active and it's at the bottom, okay? So on here we look at this and we find zinc. Zinc is right here. Lithium is up here. Lithium is a lot more reactive than zinc, so it's going to kick zinc out and replace it. So we would end up with lithium acetate and zinc. Okay, so that's what happens in these reactions. Another thing that I wanted to point out is when you're working with water, and this was in your PowerPoint, but let's say you had something like sodium and water, okay, in a reaction, all right? What happens, and we talked about this reaction when we were going over alkali metals, but essentially hydrogen gas is going to be produced. And it's a little bit hard to see that. So the easiest way to know what your products are going to be when you have water is going to be to write it as hydrogen hydroxide. Okay, so that you can easily see we have hydrogen and it's going to switch with the sodium, all right? And so we're going to have, so that your cations are going to switch. So you end up with sodium hydroxide. And our hydrogen gas, okay? And that hydrogen gas, the quick reaction that takes place is what causes the massive explosion, okay? If you were to put sodium in water, like a big hunk of sodium in water. And we talked about that with all alkali metals. When you put them in water, there's a massive explosion because that gas is produced really, really, really fast. And if we were to look at this, we could go ahead and look at our activity series and see that hydrogen is down here and sodium is up here, sodium being the more reactive metal, so it's going to replace the hydrogen in the reaction, in the compound, making sodium hydroxide, and then hydrogen gas. All right, so you have to use this little activity series to decide if the reaction will actually take place. Was there anything else from the PowerPoint that I wanted to make sure you understood before we go through examples? I'm just checking. Just remember, like replaces like. Okay, so you're not going to have a compound that comes out with two cations, because remember, all compounds, those charges have to balance. So you're going to have a cation, which is positively charged, and an anion, which is negatively charged. All right, so let's do some examples from our worksheet. I'm just going to start with number 1. It gave you calcium and magnesium sulfide. Okay, and it asks you to predict the products. Okay, so we go to our activity series, and you can see that calcium is right here. Okay, and magnesium is down here. There's calcium is higher than magnesium, so we can look at this and say, okay, calcium is more reactive. It will replace the magnesium, and we would end up with calcium sulfide and magnesium. Ran out of space, so I just used the formula. So that would happen. All right, let's go on to number 2. Oops. And I gave you sodium and silver chloride. Okay, what are your products? If you were looking at this, silver is the least reactive metal, so sodium will of course replace it. So we would get sodium chloride and silver. Okay? So there's 2 fairly, hopefully, straightforward examples. Now let's go down to number 7. I wanted to look at this one. For 7, I gave you silver plus sulfuric acid. Okay. If we look at this, first of all, a couple things. Number 1, silver is the least reactive metal. It's not going to replace anything. So you would know that there would be no reaction based on that. But if you're still confused and you want to look at your activity series, okay, silver's at the bottom. And what is your cation here? It's going to be hydrogen, right? Whoops. Because if we were going to write out the chemical formula for sulfuric acid, it's H2SO4. And hydrogen is right here. So silver is below hydrogen. The silver will not replace the hydrogen. So no reaction would occur. All right, I hope that helps going through a couple examples. If you have some questions, you can email me or call me, and I will try to help. Have a good day, you guys.